Okay, so we're going to go ahead and get started. My name is Ben Follett, and I am the U.S. Product and Marketing Manager for SCIA, actually in North America. And today, on behalf of the SCIA Product Department, we'll present to you what's new in SCIA Engineer version 16.1, which was just released just a few weeks ago. And so what is new in 16.1? So 16.1 further strengthens the solid foundation for structural design laid in version 16. So really a lot of improvements on the functionality that we had released in version 16. More specifically focusing on concrete design, steel design, composite design, as well as numerical analysis, BIM, and then overall usability based on some customer feedback. So in today's webinar, we're going to go ahead and talk about some European design needs, the design needs that were implemented for the U.S. market, and then some general improvements in BIM and usability that were created for the entire market. So let's first start with the new European design features, in that beginning in concrete. So one of the first new features was the rearranging of the concrete design settings. And so this new development of SCIA Engineer in version 16.1 includes the updated concrete settings. The concrete settings are one of the most critical parts of the design process because it includes all of the code parameters and conditions for the concrete design. And so making it easier for users to find this information and being able to kind of filter through the information really can create some workflow efficiencies. And so all the parameters related to the conditions of reinforcement and even the definition of the new basic and additional reinforcement, which we'll talk about, have all been moved into really user-friendly spots. And now it's really easy to search and sort for different functionality with some of the filtering tools. Like I mentioned, the user now also has the opportunity to define basic and additional reinforcement on the beam. So under the reinforcement design menu, the designer can find these, the design defaults menu, and within this menu, they can set the condition for the calculation of basic and additional reinforcement. So it's now also possible to select the necessary reinforcement from a predefined library while also being able to set like a fixed number of bars. And so it's really very easy to edit the reinforcement in any given member with just a few clicks. And so here, just one of the options within the menu is to set or establish some basic reinforcement kind of layouts and templates. And so within these templates, you can apply these then to whatever beam or column that you're looking at the reinforcement for. One of the other new features, actually, this shows kind of the old way in SCIA was we would calculate reinforcement and show you graphically on the model just the area of reinforcement that was calculated, whether it was for shear or longitudinal reinforcement in beams or columns. Now it's also possible to show the reinforcement as number and spacing of bars. And you can set the basics for the size number of bar that you want to use or the limits for the size number of bar that you want to use within the general setup. It's also now possible to review and check the reinforcement, so you can do a unity check based on the area of steel provided or the area of steel required on a given member. And all that, obviously, in detailed fashion is shown in the detailed output. And so here you can see just kind of the detailed output based on the provided reinforcement. There are also a significant amount of updates for, the 1D members, or 2D members, excuse me. And so in this particular model, we're going to go ahead and look at some of the 2D member options. And so I'm just going to go ahead and refresh the design. We're going to run the check to get the internal forces on all the members. Actually, this is the 1D members, I apologize. And then we're going to go ahead and look at the reinforcement design. So the required reinforcement, AS required. So this is just the typical AS required. I'm going to go ahead and select first all the beams, and so we're going to just design very quickly all the beams, and so you can see how quickly in this case it's going to design those 58 beams. Now I'll jump into the concrete settings, and we can go ahead and change some of the settings, and you can see by the search tools we can go ahead and in this case, neglect the reinforcement due to torsion. And so we can then run the design again with the fact that we're neglecting torsion. So we'll get that reinforcement. Again, we've got the reinforcement showing in kind of the old way where we're just showing the area reinforcement. We can also change it to one of the new features, which is showing the bars and the bar dimensions and the bar spacings. Now, as we mentioned before, we can also show the shear reinforcement. So this is going to just be the shear reinforcement on each individual beam. This is in area of steel. We can also go ahead and select a specific beam. We're going to select all these beams using the filtering tool, which are the same. And then go ahead and show the shear reinforcement one more time. And then actually show the unity check of the max reinforcement. So this is the reinforcement based on against the max reinforcement. And so here we can see the setting that we have for that rectangular section. We can switch that template and then run the design again to get a different max unity check. We can also see the unity check based on the provided reinforcement. So here we're going to actually show the provided reinforcement. So this is based on that template. And then show the bars based on what we have in the template. So those are the bars that we have in the template, both in top and bottom. And then again showing the unity check based on those bars are provided. And so we can see the spots where we might need some additional reinforcement. And so we can go ahead then and validate or look at a very specific member and look at the table results of that member to kind of see exactly what's going on. So we've got the area steel provided. And we can go ahead and look at the detailed output to see exactly what's going on. So we've got provided bars, required bars. We'll go ahead and look at individual sections. So we can look at the middle of the beam here. We'll refresh the table. And so you can see we're identifying the section on the beam there. And so we're looking at that particular section. And then seeing where we're failing. So we're not required to have any bars, but we are required to have some more bars, some additional bars at the bottom, and some additional bars in tension there. So we're going to go ahead and we can go ahead and update that, or we can use a different setting of information. Now, one of the other new features, well, not a new feature, but some updates, were in the concrete section check. And so we've really kind of reworked the workflow for the concrete section check. So in this, we now have the option to directly store the section check project for editing within the engineering report. So we can save it right for the engineering report. You also have different values which we can see now on the model. So you can see these unity checks and the table results from the section check now right on the model. So you can better kind of identify what's going on. And then it now has dynamic regeneration, just like other reports and other parts of the model do with the engineering report. So here's a little vignette, a little video about the section check. So the first thing I'm going to do is I'm going to enter into the concrete 15 service. And I'm going to go ahead and look at the internal forces. Now we already have some section checks. You can see the SC1 and SC2 already defined. So I'm going to select this kind of row of members, this B35, and we're going to go ahead and look at those specific members here. So we've already got our section checks kind of defined. Now we can go ahead and select the given member and select a particular section. And so the sections are based on the mesh size, and we can then enter into the section check. And so within the section check, we can enable different provisions that we want to actually check. In this case, we'll enable the detailing provisions. And we can go ahead and enable or disable different parts of the detailing provisions to see how that changes the section check. So we'll define the templates, define the reinforcement. We can change the input data, so we can change the offsets. We can come in here and change the bar spacing or the stirrup spacing. So we're going to make the stirrups a little closer together because of the required value there. So now we can see what was required. So it's really easy to make those changes. Now if we look at the results, we can jump back into section check results. We can go ahead and look at, for a combination, whether it's for serviceability or ultimate limit state, we can go ahead and see those unity checks. And so we've added that new section, so we see those unity checks. And we also see the unity checks for serviceability. Now in this case, we see that we have a failure at that for serviceability at that section check. So we're going to go back into that and look at why we're failing. In this case, we're failing in crack width. So we're going to go ahead and add a fourth bar on the bottom here, and then we can just save and close that to re-update the model. Now we can then just easily go and rerun that section to then see exactly how that's been updated. Like we mentioned, we can see this updated information within the table input. And then once with the table input, we can go ahead into the engineering report and use the section check results and just bring those check results right into the engineering report, just like any other data or any other input or output that we created in SCIA. And so we can just select it based on the same parameters and then bring in the information, whether it's a brief output or a more detailed output. So the first one here we'll add as a brief output. We'll go ahead and pick from a list to just identify those particular section checks. We're just going to use the one. And then we'll go ahead and choose a combination, choose maybe for the serviceability state, and then choose a more detailed output, in this case the standard output, to see some more detailed information for exactly what's going on. So in summary, we've kind of created or created a new workflow. So we've got a high quality product. So we've implemented some new rules. We've created more speed, so it's much faster now. We have clear and verifiable results, as we've always aimed to do within the concrete service. We have a clear and understandable interface, so we're really trying to use some feedback from the users in the market to set some really user-friendly settings to make the workflow very clear. And also this new design workflow, I think, really establishes a shorter learning curve, and so it's much easier now to learn how to use the new concrete functionality, learn how to use the section check, and really optimize your designs using your concrete designs using SCIA Engineer. So let's now move on to some new features in steel for the Eurocode. So one of the most important ones was the base plate design. So we've done some base plate refactoring. So we've added the addition of haunches, both single and double-sided. We've removed some old sections from the code using methods for beam column connections, which were also used for the base plate. And then we've also added some new code-related design additions. So some compression design, a proper method for the calculation of moment and axial forces, some proper method for rotational stiffness and other stiffness calculations, and then also some new calculations for anchorage and anchor bolts. We've also improved the report. So the layout now follows the structure of the Eurocode, which makes it much easier to kind of verify exactly what's going on and exactly what you're doing. You can see all intermediate calculation steps, and then also all the references to the applied code articles exist within the tables and within the intermediate steps. So it's very clear exactly what part of the code that we're looking at. And so again, here's just a short video. I've got this model structure with composite deck and pad foundations. So in this case, we're actually going to do a simple base plate design. And so I'm going to go ahead and select this foundation. We're going to go ahead and use a frame bolted connection. And we're going to go ahead and choose that, yes, it is going to be a base plate, and yes, it's going to be perpendicular to the column. So we'll enable the base plate here. We can go ahead and set the base plate settings, so the extension beyond the member itself. I'm going to go ahead and enable the rendering so we can kind of see everything as we add the different parts of the base plate, so the welds and all other parts of the plate. So if we select back on the connection, we're going to go ahead and add in the haunches. So there's the top and bottom haunch. You can see that when we add the haunches, based on the parameters of the Eurocode, based on the spacing requirements, the haunch will change size. We can also go ahead and modify this on our own. Next, we can go ahead and add the anchorage. So if we select the anchorage, we can go ahead and then select our bolt assembly and select our pattern. So we can add four rows of bolts. Now you can see in the bottom below the actions, you can see these notes that are always updating to tell us exactly kind of how our spacing is working based on some of the limits and based on some of the Eurocode detailing provisions, so on and so forth. And so if we change the spacing and we change the external internal distances, we can see the different limits and how the notes are updating to tell us kind of what's going on. And so now we can see that all distances are within the limits. We can go ahead and enable different rows, and so we can add 4 rows of bolts so that we can have, or in this case 5 rows of bolts so that we can have an appropriate number of bolts. We can also go ahead now and apply the concrete data. So we can set the data so that the base plate actually knows what the foundation dimensions are. So in this case we'll set the length, the width, the thickness of the grout. We can set the bond condition. So this goes to the bond checks that are done based on the Eurocode here. And so we can set whether or not we have good or poor bond conditions. So we're checking the grout strength and compression in this case. We're also doing all the checks for the anchor bolts. And so here, setting the anchor data, we can set a curved or a different type of anchor data. So we can go ahead and set this information and see now these different types of anchor bolts. So here we can see that connection as we are drawing it being updated graphically. Now if we look at the output here, we can go ahead now and see that the rewritten output follows the organization of the code. So we see all the input data, and then we start jumping into the code-related parts of this calculation. So all the strong axis calculation, then we've design moment, compression, so on and so forth, right out of the parts of the code. So here we can just see the code, and these are all the parts that we're comparing directly from the code. So here's the articles, and there was the code, obviously. So it makes a lot of sense as you're trying to design this in a linear fashion. Finally, we see the stiffness calculation. That's also been updated. So we've got a new updated stiffness calculation and design calculations for the anchorage. So all of this is based on the provisions of the Eurocode again. And then finally, the results for the connection stiffness and so on and so forth. We can also now use this base plate design with inclined columns. So I'm just going to go ahead really quickly here and change the properties of this node. So I'm just going to move it a meter. We'll lose our results certainly, but now the column's going to be inclined, and when we incline the column we can see that automatically the base plate and the haunches change with the column. And so we can automatically then rerun it if we wanted to and see the new results. We've also made some updates for steel connections, so beam resistance at a haunch end. So a new way to evaluate the beam at a haunch end similar to the failure at a column stiffener and its relationship to the possible failure at the beam at the stiffener and the beam. And so the same calculation method is used for both beam and column design in the Eurocode. Also, by taking into account limiting combined resistance of bolt row groups in the framework of the component method, SCIA Engineer is capable of capturing more complex failure mechanisms. So yielding that spreads over multiple bolt rows, punching of large segments of the end plate in the tension zone. So just different, more complex calculations for more complex connections, whether they're with haunches or with more complex bolt settings. In terms of bolts, we've also included new libraries for bolts, screws, nuts, and washers. So added some new ISO and EN code libraries so you can see what have been updated and also what have been added just as new. Additionally, we have some updates and improvements for composite design in the Eurocode. The first was the added provision for the weight of fresh concrete in the construction stage. So fresh concrete typically weighs more due to its higher water content, and so it's estimated that the density of concrete is about 4% higher in the fresh state than in the dry state. So additionally, that's typically taken into account as a variable load because of just some different options based on heaping and the fact that there's some different things that are going on with the concrete not fully cured yet. And so the user can use this as a variable load, or if they want to make it a permanent load, even if they want to eliminate the fresh state altogether and just use the standard dry state, it's possible as well. Additionally, the SCI publication for the resistance of headed shear stud connectors and transverse sheeting, which is used in the UK in addition to the national annex, has been implemented. So it prescribes a modification to the shear resistance of welded studs in a composite slab, taking into account the geometry and behavior of more modern steel sheeting. So this now is included, and so by supporting this, it complies with both the international code and just the common engineering practice that engineers are using in the UK. Now just some basic analysis improvements. The Dutch Standardization Institute recently released the latest Dutch practice NPR 9998 with regards to earthquake-resistant buildings, and so this contains details for the definition of the new seismic spectrum, and so you can see this in the new seismic spectrum settings. So this spectrum can be used in two different linear calculation methods, whether it's the equivalent lateral force procedure, which is applicable for regular buildings based on static analysis, or the calculation according to modal response spectrum, which is really a dynamic analysis which is applicable for all buildings. Before we get into some more general design requirements, let's go ahead and talk about a few of the design updates and changes that we made for the US market. The first again being in concrete design. So there's a new concrete design solution for 2D members. So this brand new solution is designed for slabs for ACI 31814. With this solution, it's possible to calculate the necessary reinforcement for shear bending for the ultimate limit state, including all the detailing provisions required for the code. The design is also presented in an improved standard and detailed outputs, including all the options to display the reinforcement in terms of number of bars and spacing of bars. Additionally, we've created a new setup, so this is now more similar to the Eurocode setup. So it's a really kind of usable workflow for being able to look up all the different parts of the setup, all the design requirements to be able to set the bars and the bar spacing, the bar minimums. So this is really a user-friendly way of setting this information, which then obviously drive the output. And so we've got new detailed output to show exactly how the calculation is going, including all the internal forces, all the other specific data, all the calculations and the summaries for the unity checks for shear and bending and so on and so forth. So you can see exactly what's going on for the concrete slab design. For composites, the first improvement for composites, which we considered to be essential based on some user feedback, was the calculation of the resistance of the beam with web openings. And so this is according to the AISC Design Guide 2, which is steel and composite beams with web openings. So this new feature allows us to do the following. So we can, we now adhere to this design guide. We can calculate moment and shear resistance at these web openings, both in the construction and final stage. This is included in the auto design routine, so it's just included right in the auto design routine after you define the specifics of the opening, and then also the ability to include and define stiffeners where you require them. So you can do a circular shape or a rectangular shape with stiffeners. And then also you can see these are included in the detailed output. And so it's just going to be included in the optimization routine of the project. Additionally, another user kind of feedback item was the option to ignore composite action in negative moment regions. So a lot of times people are not taking into account the composite action, the concrete and the steel studs in the negative moment regions over supports, for instance, and so they just want to be able to use the steel beam alone. It's a very conservative approach, but kind of a standard way of doing things in the United States. And so the user now has the option in the general setup on how they want to specify that for the entire project or for individual members. And so just giving the users more flexible workflow to kind of do what they want to do and how they want to do it. From the analysis side, some really nice improvements for seismicity and the equivalent lateral force procedure from ASCE 710, which was implemented in version 16. So including some new seismic spectrum information, new calculations of the approximate fundamental period. Also, new seismic load combinations per the ASCE, including the ability to use the orthogonal method with both seismic load directions in the same load combination, vertical distribution, redundancy, and overstrength factors, and then also the ability to include accidental eccentricity automatically. And so all of this is included now directly through being able to just automatically create this. And you can see kind of a screenshot of that. Just a quick little vignette again on the seismicity. I'm going to first jump into the loading and the seismic spectrum. And so here, instead of, we're going to go ahead and define an IBC spectrum. We'll look at the code parameters, and so we can see some of the new features. So we're defining now the R factor directly in the spectrum. The SS and the S1 in the long period were always there. We can see the calculation of the seismic risk category and the seismic design category. With all that information defined, we can go into the load case, and we can go ahead and, sorry, I don't know why the screen got smaller there. We can go into the load case, and we can see then the definition of the equivalent lateral force, and so we can go ahead and calculate the approximate fundamental period now directly by using the code parameters. And so we'll assign the response spectrum, and we can see here we're just choosing the code parameters. We'll go ahead now into combinations, and for this data we'll go ahead and create then just a seismic combination. And so this seismic combination we'll choose as an IBC, LRFD, or ASD combination. So we'll choose ASD. We get a note here that's telling us just about how we need to set load groups in case we want to take into account the non-orthogonal load conditions. And so in this case there we can see the setting of the factors for redundancy, vertical distribution, or overstrength. So in this case we're going to go ahead and include overstrength, and then we can see the overstrength factor. We'll click OK. We've got our seismic combination. We can then click Close. Now if we go into the solver setup, obviously when using the ELF method, we have to have the improve reduce system set, and then we can go ahead and run our linear calculation. And so since this is a linear static analysis, this will all just kind of run right within the calculation here, and so you can see the task queue viewer to see all the steps of the calculation that are generating. So the calculation's finished. We can now go ahead and check out some results. So we'll go ahead and look at story results, and so this will give us the applied forces based on the seismic loading at each individual story. So we'll look at the seismic load in the X direction. We can see it graphically, but it's probably easier in this case to see a preview of this, to show this in our table so we can see the different distribution factors, the period that was calculated, and then we could also add this information to the engineering report if we wanted to. So let's go ahead and talk about some general improvements for both markets, the European and the American market. So the first was now some more clear settings for second and third order analysis with just some better explanations of kind of what the user would be doing when they use these settings. So it's a reorganization really of the settings for the selection of the type of the nonlinear analysis. So first you can choose whether you're going to do a second order, which is essentially a P delta, or a third order for large deformation analysis. And we can also see very plainly, when you select second order analysis, we can see exactly kind of what that first, second, or third order means. And so there's really no more guesswork into exactly what's going on within the software when you're using these types of nonlinear analysis. The second set of general improvements are in the realm of BIM, Building Information Modeling, and so the first is within the IFC file format. So we've created a new IFC toolbox, and really the new IFC toolbox aims to improve speed and memory efficiency. And so really with this, the primary concern was a speed issue. And so now the import of the IFC is much faster. You can see based on this just kind of little benchmark based on the old and the new. We've also optimized the memory, so this gives us the ability to import larger IFC files, import and convert larger IFC files. So just giving the user, again, more efficiencies and more robust workflows for using IFC models, whether they're structural, architectural, or they're just models that they're going to use as reference geometry on different layers. In addition to IFC, SCIA has always included a robust link with Revit, and so we've got a new build of the Revit link from our sister developers at CAD, which includes the update for both version 16.1 and also Revit 2017. Some basic updates include the just export capabilities, including numerical cross sections, also slanted columns, and some other just kind of smaller improvements in the support of the Revit link. Now we've done a decent amount of usability studies with some of our new feedback features within the software, and so really based on this usability study, we were able to add some nice usability features based on some customer feedback. And so the first, even though it seems so simple, is just the ability to add different margins for even and odd pages. So we can swap the margins on each side, and so we can just, a better way to create the output. We also have better interaction with the 3D model and tables. And so in this case, the first option here, we can filter to show only the rows for selected objects. So for instance, if we wanted to filter based on load case or filter the table only based on the selected objects like these beams, and for instance, we could do that filtering. We can also utilize activities then in the table. So there's just an activity button, just like you have activities in the model. You can filter by a specific activity directly in the table. We also have better manipulation of the tables. So when you're copying and pasting directly from SCIA to Excel, you now get the header copied directly into Excel, so that gives you a better idea of exactly what's going on and what kind of tables you're using. There's now a simple round feature, so if you wanted to round everything to 1 decimal spot, you could use this round command to round to 1 decimal spot so this is going to actively manipulate the model. It also includes an extension of input for 2D members and load panels, and so those are included as new options to basically be able to modify within the table input, which wasn't an option before. We've also created the opportunity to create new customized toolbars and user-defined shortcuts. And so I just have a short little video on these kind of customized shortcuts. So here I'm going to go into the customized toolbar, and I'm going to select the toolbars, and I'm going to create a new toolbar. And so I'm going to create a results toolbar because it's not a standard toolbar that we have in SCIA. And so with that, now we have the ability to add any buttons or commands. And so I'm going to go ahead and add in maybe the displacement of nodes and some 3D displacements, 3D stresses into this toolbar. I can go ahead and then move this toolbar, dock it, and now use this toolbar as any other toolbar. And so now if I select the button, it jumps right into that result. Now I still have to hit the refresh button because it's not automatically refreshing it when I click that, but it automatically takes me into that specific result. I can do the same thing with jumping back and forth with displacements and other results. So if I choose the 3D displacement here, again, we jump right into the 3D displacement. We can change the load case or load combination that we want to look at, and then go ahead and update exactly what we're looking at here. Now it's also possible to customize keyboard shortcuts, and so in this case, if we want to go ahead and look at a 3D stress keyboard shortcut, we can say, hey, for Control D, that's what I want my 3D shortcut to be for stress, and Control S is going to be for displacement, and so we're going to assign that. And so now if I close out of the system, and instead of hitting my customized toolbar, if I just hit Control D or Control S, we're jumped right into that 3D displacement. And so creating customized shortcuts just gives you more flexibility in using the model and allows you to really kind of set your own workflow and make SCIA work exactly the way that you want it to work. So to kind of round out exactly kind of everything that was done in SCIA Engineer 16.1, obviously we've created new complete 1D member concrete workflows. So there's a new 1D member workflow for Eurocode, a new 2D concrete design for the ACI. We've improved the section check with more integration with the section check in the engineering report, more integration with the section check and the graphical output, being able to see all the unity checks and all the information in the section check directly on the model. We've made some improvements for composite design for both the UK and the US, both in the fresh state of concrete, the self-weights, the web openings, some different UK provisions for the Eurocodes, some steel connection updates for the Eurocode for base plates, and also connections with haunches and connection with multiple bolt rows. Seismicity improvements for both the NPR and the ASCE with equivalent lateral force procedure and some updates there and seismic combinations. Obviously some BIM improvements both in the IFC and the Revit 2017 link. And then obviously the usability improvements. So really focusing on kind of user feedback and the user's ability to kind of do whatever, or excuse me, kind of really create a workflow that fits exactly to what they want to do and how they want to use SCIA Engineer. And so if you have additional questions about SCIA Engineer 16.1, you could visit SCIA.net for some of the release information and some of the kind of overview of features. This webinar, as soon as we finish, will be uploaded onto YouTube, and so you could view this webinar again. You could also contact support@SCIA.net if you have any questions. Also, I wanted to remind everybody that the 2017 user contest is open. So if you visit contest.scia.net, you'll get more information about the user contest, about the judging, about the timelines and the dates, and about all the information that you can submit for any different types of your models and different projects. And so at this time, I think there may be, I don't know if there's any questions. I know some of the people have been answering questions. I think that we can open up the time for questions here for just a minute. So if you have any questions, feel free to type them into the questions box, and we can go ahead and answer some of those. I don't believe the negative moment effects can be neglected in the UK version of the composite design. I think this is right now for the US only. But certainly if it's something that is a request, we can add it into the request of the UK version of the composite design functionality. So currently a load panel cannot yet act as a diaphragm, but there are some new improvements coming with a modification of 2D members, in the sense that we're now going to work to combine the effects and the functionality of a load panel and a 2D member to be the same. And so now you would have all the functionality of a load panel and all the functionality of a 2D member in one element. And so that would effectively give you then a load panel that can act as a diaphragm. So SCIA does have some post-tensioning design functionality, not in the US code, and so you can analyze and model post-tension, but not design post-tension in the US code. So somebody had a question about notional loads. The notional loads are taken into account in the sense that you have the option to apply geometrical imperfections, both according to the AISC at least, geometrical imperfections both globally and then locally on the member. And so those geometrical imperfections based on an inch per foot basis are actually what notional loads are used to calculate. And so it's actually kind of removing the requirement for notional loads. And so notional loads aren't necessarily needed then if you take that step. Certainly if notional loads, you can apply your own notional loads, but at this point, you know, there's been some discussion about adding notional loads just because it's kind of an accepted way of doing things, but you know, we can certainly still discuss that. As far as seismic design for EC8, I believe it's completed just like seismic design for AISC or excuse me, ACI is done. It's done using EC tools, which is a plugin that SCIA has, and so you can utilize EC tools for concrete seismic design from EC8 and also from ACI. Okay, I think we've answered a few questions. If you have additional questions, remember to contact support@scia.net, and then if you want more information about the release, remember to either see scia.net or you can kind of review this webinar after we upload it here to YouTube. So thank you very much for your time, and I hope you have a good rest of your day. Bye-bye.